Okay, let's start. We are already 5 minutes late and people will still join. So, good morning everyone. Welcome to the 12th edition of the SOFA Technical Committee. Let me just remind you first that we have a big web page here, sofaframework.org/STC12, which contains everything that we will use during the committee. So the agenda is here, the link to join is here, everything is here. So do not hesitate to use this link to come back if you have to go or anything else. So first I will present you the 3 days and the program of the 3 days, and then we will shortly start. So for the 3 days, basically the 3 STC days are split in 2 main parts. First, the roadmap day, it's today, and second, the 2 other days, which will contain technical discussions and the usual coding sprint. So for the first day, I'd say it's the most important day because it's the day where we will define the next roadmap, so the 22.6 roadmap for SOFA. And of course, we will also review the things that we have that have been done in the last 6 months, so the 21.12 roadmap. First, we will start with a bit of consortium news. Next, we will do a big roundtable to get to know a bit more about what everyone is doing. So the idea is to present yourself, tell what you did in the last 6 months with SOFA, and tell what you plan to do in the next 6 months with SOFA or around SOFA. The idea is to spend at most 5 minutes by person, but since we are very not a lot, I guess there is no limit. So the discussions will be open. And next, so third part of the morning, we will talk about what happened in the roadmap project. So 6 months ago, we defined the 21.12 roadmap, and so now we will review what has been done on this roadmap. This afternoon will be dedicated to defining the next roadmap. So this is very important for us, for the consortium and for the whole project, to announce what we want to do with in SOFA and where we want SOFA to be in 6 months. It's very important for the community. It's very important for us too, because we want to know, we want to make sure that everyone is okay, moving in the same direction. So to do this next roadmap work, we will first speak about what project could join the roadmap for 22.6. So we have 3 criteria for a project to be a potential roadmap project. The first one is someone is the main contact. The second one is that we are sure that the project will evolve in the next 6 months. And the third is that we are able to list around 5 objectives for the next 6 months. So we will speak again about these criterias because it's important for the next steps. After selecting the potential project for the 22.6 roadmap, we will split in breakout rooms to really go in details on each potential project and to try to define around 5 objectives for the next 6 months. And then we will come back together at the end of the day today and review what has been discussed in the breakout rooms and finalize the next roadmap by just saying if we are okay with the objectives that have been defined for each potential project. By the end of the day, I hope we will all agree on what is the 22.6 roadmap and what are the objectives for 22.6. Days 2 and 3, as I said before, will be dedicated to coding sprint as usual. So there is a link to all the tasks that have already been listed, but you can also add tasks yourself. So feel free to do it. And there is also an agenda. So this is the link here, STC 12/discussions for technical discussions. So there is also we will create breakout rooms during days 2 and 3 for everyone to speak about literally anything they want. So there are already a few discussions that have been scheduled. So you are free to join them if you want, or you are also free to reserve the free slots in the breakout rooms if you want. So everything is on this link. Here is the schedule for now. So as you can see, there is a lot of slots that have been taken for discussions on very different things like Caribou plugin, um, how to replace get context by links, or deprecation. So a lot of different discussions will take place during day 2 and day 3. So first thing first, a bit of consortium news. I will let Hugo. I keep the control on the presentation if you don't mind, Hugo, and I just let you do the speaking.
Yep, thanks. Good morning, everyone. Good afternoon if you are more, I would say, Asia or Oceania located. I already mentioned some of this news yesterday, but that's for giving you some updates about the status of the consortium. You know that the consortium is made of members that are actually either paying for or donating to the consortium, so basically to SOFA, so that we, as I said yesterday, the more there is, the more engineers we can actually expect to work directly on SOFA. So there is no money to get in the pocket of Guillaume or neither mine, but it's just money for people to work on SOFA. We have actually three partners today, official partners that are Asan Medical Center, a medical center in South Korea, research center in Germany, which is Fraunhofer, and a French company, which is Insimo, working on medical simulation, as I said yesterday. And soon we should have also additional French companies. But definitely, whether you are French, whether you are, I don't know, Chinese, Japanese, whatever, all the support is as well welcome, and that's one way of supporting, becoming a member or donating, as Infintech 3D did in the past. The University Milano, University Verona, and finally Harvard Medical School as well. So for this year, also to give you an idea of what happened basically in terms of activity in the community, we are actually, as you might know, providing training sessions. Last year we had like 32 people trained. We did as well some conferences early in early 2020, like in the first months of 2020. But else, I would say direct training that we did, dedicated training that we did. We trained actually 32 people on SOFA, and this year we're like 50% more, up to almost 50 training attendees. So that's a good trend for us, meaning that interest in SOFA is growing. People are expecting to level up on SOFA. If you know people that need actually to level up on SOFA, or that need specific topic of training, do not hesitate to let us know, because we are actually providing new training materials and so on as soon as possible. And as we did for the introduction course, which is already online for one of the previous version, I think slowly, little by little, we'll do some kind of MOOC or similar stuff to help people to level up in SOFA. For the ongoing operations, so the ongoing developments, so that's you're here, guys, of Fred, Robin, and Alex, who are the three engineers, and Jean-Nicolas, who ended his contract recently. So so you are, guys, three engineers on three specific topics, namely modularization, which is cleaning the core of SOFA and making it really modular. And this will really help the building of new application, of new projects based on a clean core of SOFA. That's also what we call SOFA Next Gen or SOFA NG. It will be in today's discussion. Second, the work of Robin, and he will also talk more about that from the Mimesis team, working on the coupling between SOFA and AI. That's what is called Deep Physics, a Python platform to couple SOFA and potentially more as well, and AI libraries. And finally, Alex, which is working in the Defrost team, working on the modernization of the constraint pipeline and resolution. Actually, it's I think we can say that it's way broader than that. It's also the work of matrix formats in SOFA, matrix assembly in SOFA. Then it will go towards constraints assembly of the matrix for the constraints and the constraint resolution. So there is all the question of then the linear solvers that will come with it. And the library, the Eigen library, which is never really far from the discussions. So that's the kind of things that happened. As I said, 15, I think I remember 15 developers for about 15 developers for the last release. I mean, the more we are, always the better. Again, for statistics regarding INRIA, they are really expecting that more and more people do contribute. So never hesitate to contribute, even if it's a small improvement, or even if you're not sure it will be useful for the community. It's always better for us to see you contributing. It's a sign of good health for the project. That's repeating that was a slide that was here yesterday, maybe with a small different image, but that's really the criteria. So if you can work on one of those criteria, anyone contributing, citing us, increasing the involvement of you and your team in the technical committee that we are having today, that's really something that matters for so I would say the SOFA headquarters. They are really looking at how many people are getting involved, and the more we are, the more consortium member, the more contribution, the more citation there will be on SOFA, the more actually engineers there will be dedicated on SOFA as well. So yeah, that's really the direct link. Yeah, that's sorry, I was reading the chat. That's really the direct link between what you do and the impact on the project. So as soon as you are contributing in any way, which is your own way, it will motivate definitely INRIA, which is the main, I would say, the main carrier and manager of the project, really to support even more the open source project. So the more you do, the more you'll actually get more development for yourself and for your project. That's why we are writing it's self-profitable. And one of the example that Damien mentioned in the chat is that obviously, I mean, contribution is one of them, sharing code, new models, algorithms, or doc of helping people on the forum. That's especially, so doc, codes, and so on. It's typically things that you can actually then later on apply for the open source prices that we rewarded yesterday evening.
No, it was not that.
Okay.
I was speaking about the nationwide price for open source. We should apply for the 7th of December.
Okay, yeah.
And because they are evaluating the collectivity.
Yeah, definitely. So sorry, I misunderstood your point. But yeah, indeed, we're gonna apply. Actually, it's the big deadline after our nice SOFA week. The idea is to then work on a specific deadline, applying for the open source. It's a French price, but at a national scale for us, to proving and highlighting a really community open source project, and the activity of the community is one of the main focus. So the more you are active, also the more prices and the more visibility SOFA, therefore yourself, you're going to have. So that's again a self-profitable aspect. And if you have prices for open source in your own country, just let us know. We would be really happy to help you apply for that. Even if it's not only SOFA, but it's SOFA and your project, just let us know. We are here definitely to help that kind of application. And that's again the last. I think it's the last reminder about the community workflow. For different places, I mentioned already that there was the Gitter for daily messaging between the developers. Today's technical committee, which is really reviewing the last 6 months and designing the next 6 months activity. with the coding sprint and the long-term project discussions. SofaDev, every week we are having development discussions. So if you want to join, it's completely open. I mean, open if whether you are master student, whether you are a professor in a US university, whatever, just you are always free to join every week or once 1 week, sometime, anytime you'd like. It's always good to have some news during this casual weekly meeting. And finally, the forum for community support. And again, this should evolve again soon, as we said yesterday.
Thank you, Hugo. So we are perfectly on time. So it's very, very nice. So the idea for the rest of the morning is to do a big roundtable and to give you guys one by one the mic to speak a bit about what you do, what you want to do, and who you are. It can also be interesting for a few that don't know you. So I wrote 5 minutes max, but actually we are 20, so it's okay to if a few people are doing less and a few are doing more, it's okay. You can have some slides or not. It's up to you. There is it's definitely up to you. And after this big roundtable, which will be split in two by the coffee break, we will do the review of the 2112 roadmap with the six projects that were on the roadmap. So there will be a few presentations also in the end of the morning. So for now, the roundtable. I know that Christian, you wanted to speak first. For
Yes, I'm sorry. I'm also in another meeting today.
Yeah, no worries. So the floor is yours if you want to speak first. If you have slides, you can show them. It's your turn.
Welcome, Christian. Yeah, you should have the sharing button down here.
He asked me to install WebEx.
You shouldn't have to.
Yeah, it's not necessarily.
Maybe is it working with Safari or not?
I don't know.
Chrome and Firefox. Sorry, I will just change my.
Okay.
Sorry, I come back.
So it's going to be a presentation on soft robotics related activity and the development that are related to the activity of Christian. And that's going to be, I think, related to one of the aspects we just mentioned the name earlier, but new project that will actually start around the community. So this kind of information is also important, as we said yesterday. So I'm seeing like Team, Tang, Martin, and so on. So anything you are actually starting or is going to start within the next months, it's always good to hear about that.
And in the meantime, so it's not the coffee break yet, but I wanted just to show you. Oh, why did it? Did I shut down my? Oh, because Christian is here. Okay. So go ahead, Christian. But we can't hear you. Oh, you're muted.
Yes, you hear me?
Perfectly.
Yep. So it's working with Firefox. Okay, I wanted to talk about T-Rex, because it's I think it will be an important project for SOFA in the coming years. So the idea is that the French government has done a call for research infrastructures, and we have been successful by answering for infrastructure in robotics. And what was so the infrastructure in robotics is, so the idea is that we managed to make to unify somehow the community in France and define 6 national platforms on robotics. So there is I will detail this 6 national platform, but it's more or less a material platform. And there is 3 transversal platform, one concerning designing and prototyping, one concerning manipulation, and the last one, which is the one I'm in charge of, partially in charge of, which is open infrastructure. Basically, so this is not interesting. So the idea of this open infrastructure is that we have two actions. And the first action is a platform dedicated to digital twins of robots. And the other platform is open data and open access. So, of course, for us, what is interesting, and particularly for SOFA, is this platform of the digital twins for robots. We'll have, in fact, 2 engineers that are paid by the project, and we'll also have some money for development of infrastructure and with potential suppliers. So basically, this money is dedicated to company. So it could be, of course, I listed Insimo Infinitec 3D, but it could be also IT service company or independent developers, and that develop some modules for these digital twins. Basically, for the digital twins of the robots, we have there is 4 software that are targeted. Of course, SOFA, but also Pinocchio, and we are trying actually to be more close to Pinocchio. Pinocchio is a software for rigid body dynamics, and it's initiated by the LAS, the Laboratory of Robotics in Toulouse. And now it's Justin Carpentier who lead this platform at INRIA, in the Willow team at INRIA Paris. And we are really trying to make SOFA and Pinocchio closer. First, in terms of algorithm, and probably in the future, maybe even in the software itself. And there is also VISP, which is a software developed by INRIA Rennes, more on visual surveying. And finally, there is a software which is called BOR, but it's a smaller platform dedicated to obstacle avoidance for quadrators. So basically, I will go very fast on the different axes. There is this axis on design and prototyping where there is no digital twin. There is a transversal axis on manipulation where definitely there's this idea of using digital twins to improve the manipulation. There is a lot of people that are interested by using SOFA, for instance, for manipulating deformable objects. So, there is in this term there is a development of material platform, but there is also this idea of having the mean of modeling, simulating grasping and manipulation. And also on this platform, probably we'll have to work between SOFA, Pinocchio, and this. There is an axis dedicated to humanoid robotics and interaction. In that case, the digital twins will be probably done on Pinocchio. I'm also interested a little bit on modeling deformations, so we could also use part of SOFA for doing that, particularly if we do a link between Pinocchio and SOFA. Then there is XXI robotics. So the idea is that this XXI robotics, a very large scale robotics. You see here, it's imagine a big room where you basically have a robot with cables, and you basically your cable robot can navigate inside the whole room. But for the digital twin, they are interested by modeling the deformation of the cables. So recently, as we have developed the Questera models, the idea would be to simulate that in SOFA with this Questera model. Then there is micro nano robotics. We saw yesterday some presentation of Besançon, and they are the leader of this axis. And so we will continue basically to work with them on modeling their deformable robot. Actually, which is something that is really interesting is that when you think of large scale or small scale, for completely different reasons, it's interesting to model deformations. Then there is an axis on aerial robotic where the digital twin will be based on Bohr. I go fast. Then there is a autonomous robotics for terrestrial robotics. So it's basically dedicated to agriculture and also autonomous vehicle. So for that, it's not clear. So what type of digital twin we plan to do? We may use existing software, not necessarily one of those I have listed. And the last axis is the medical robotics, where we will work mainly with iCube, because with iCube they will develop a robotic endoscope, and the idea is to model it using SOFA. So you see with this presentation that there is a lot of opportunity, different axes that are using SOFA. And so it's for me it's a very interesting opportunity, in particular to unify how we model, how we simulate digital twins of robots. Probably one of the ideas would be to develop a unified interface of SOFA dedicated to all these digital twin of robots. So there are, again, both opportunities in terms of development for SOFA, to make a SOFA that is really dedicated to robotics, and also there is also opportunity for suppliers, because we will do some call. Of course, it will be the call will be, as it's public funding, you have to follow the rules of the public market, but we'll do that. Okay, thank you for your attention. I wanted to share you this important project, because I think it will have some impact probably on the roadmap. It could have some impact on the roadmap.
Definitely. Could you just remind us the calendar, the dates?
So the calendar, the project start in 2022. We have the kickoff project just before the Christmas holidays. And basically, the thing is that it's a long-term project. It's we have 3 years to set up the platform, and the platform are supposed to be used in research for 5 more years.
Okay.
But yeah, and so the work on the digital twin, I think to set up the digital twin, it's in the three coming years, and then probably make this platform evolve after that.
Okay. Thank you.
And maybe on a development, really on a development feature, development aspect, for if we want to take because it's a really long-term project where a lot of things will happen on a long run. But if we try to look at something very short, like very short term, like the next 6 months, what do you think could happen? In the context of T-Rex, I think it would be really the starting of like new positions that will be created. I guess also the just starting of discussions between the different framework, like Pinocchio and SOFA.
Yeah, but to my opinion, I want to. So, but maybe we can discuss that also this afternoon. I will try to join you. But for me, one action that we should start. I think, for instance, all these platforms need all these digital twins. Either they are very small scale or very large scale, or for medical application, etc. There is always an interest to be connected, for instance, to us, and simplify as much as possible this connection. I think in all case, again, whatever the scale, whatever the axis, it's probably people will want to test their control algorithm on this digital twin. So we need to provide some emulation of sensors, for instance. For instance, different visualization. If you want to test your control algorithm that is based on vision, and you want to test it on a simulation, we will have to provide an interface to plug your vision algorithm on SOFA. Maybe so. After that, there will be some specific tasks dedicated, for instance, to have maybe very realistic rendering, for instance. This could be a specific task for a specific product. But there is a common work to be done, I think.
All right, and since you are talking about rendering, it reminds me, user interfaces and so on. It would be maybe a discussion for this afternoon, but the fact that I think you are interested in pushing for a new, or at least another, but one common run SOFA or graphical user interface for SOFA, so that we would have something maybe dedicated to robotics, but maybe this at least common base could be actually widely used not only for robotics, but for the whole community SOFA and so on, not only robotics.
Yeah, of course.
May I ask?
Yeah.
Yeah, I just had a very quick question, Christian. It looks a great project, but I was just wondering. I didn't get actually who is leading the project and what type of call it is, because if I understand correctly, it's a national project, so it's ANR or something like that, or?
Yes, ANR. Yeah.
Okay, and who is leading the project? I had the feeling that actually it was lead by several people, or I didn't get actually if.
So the project, the big project, the platform is led by. I can go back to the slides. You see my slides or not?
No.
Maybe I will show you the organization. So I skipped this one. That's why you asked the question. So the project is led by Nicolas Marchand and Jean-François Kong. Jean-François Kong, you know him, right?
Yeah, right. Yeah, okay.
And Nicolas Marchand is in Grenoble. Okay. And then the project is structured in axis. So you have the main axis and the transversal axis. And I'm co-leading with Nicolas Marchand the open infrastructure. And actually, I'm responsible for the part concerning the digital twins, and Nicolas is responsible for the part dedicated to open infrastructure, to open data, open science.
Okay, thank you.
Thank you, Christian.
But yeah, really, so for your remark about the fact that it's for SOFA and also for the robotics community, my last message was really to say that in fact, I don't know if you saw in the news, but Mujoko has been bought by Google. So Mojoko is a very famous framework for modeling with robots, and simulating with robots. And so it's, I think if we want to keep an active research in robotics in the future, this type of platform, particularly the simulation platform, is very important. And the fact that we can, today, we have the opportunity to simulate both rigid and deformable robots is a very nice feature comparing to what is existing in other platforms. So I would say there is a big concurrency, but there is also big opportunities for us.
Okay, thank you, Christian. Definitely something to we will hear about more and more, and that will join the SOFA roadmap at some point.
Okay. So thank you, and for the rest of the activities of Defrost, I let the other people that are from Defrost to explain what they are working on. Okay.
Thanks a lot, Christian.
Bye bye. I'm sorry
Ciao,
not to be there all day.
No problem.
See you later.
See you. So to continue this roundtable, is there somebody with a presentation with some slides, or somebody that wants to take the mic to speak a bit? It doesn't have to be this long, so maybe a few words is enough.
Because I don't see Vlad or Sam, doing move
Yeah.
for a
So
presentation.
it will be a simple mic only roundtable.
Mm-hmm.
So maybe if I take the list in the order. Sorry, Jonas, you're first.
Okay. I'm just connect. Right. Okay, sorry. I'm Yunus Adagoyo, Yunusa Adagoyo, and I'm working in the Defrost team. I'm postdoc in the Defrost team. Right now, I'm working on 2 projects. The first one is Robocop project, where we are trying to develop a new generation of actuators. New generation means that right now what we have as implants for cochlear, what we have as cochlear implant right now is just passive cochlear implant, where you just push them. I don't know if you remember the presentation of Camille yesterday.
Yes.
What you just have to do is to push it and wait until to get the target. The thing is sometimes it's went wrong, things went wrong, and you have like the implant just go don't follow the path, and you just need small bending of the implant to get this to get the right path. Then we are trying to develop this kind of implant where we have actioners inside, and when you just need to get this deformation, you just activate them and get the bending you need in order to reach the target. There we are using the cochlear and the Coursera plugin we developed in the team. My second project, I'm working on Coursera project, where we have to ameliorate what we already have in Coursera plugin. Today we have only piecewise constant plugin model, where the thing is we are making the assumption that when we take a 1D object, we divide this object in different sections, and we assume that on each section we have the same bending. The goal is to go further, to have to say, okay, my bending is not straight, but I will use this. I will use a linear function to define this bending, and the next step is to use the quadratic function to define this bending. But we will do it. This last step, we will do it in one step, but it depends on your parameters. You will be able to choose linear or non-linear, like quadratic bending. And that's what I'm working on right now. That's all for me.
Thank you, Younes. Do not hesitate, the others, to ask to ask some questions if you have, or to take the mic at any time. There is no. We are not in a very formal format, So it's free to speak when you want.
I'm not sure, Younes. What did you say that was gonna? So for the RoboCup project, I think you wanna add basically for cochlear implant all the control part, not only pushing it but really controlling it. Is that correct?
Yeah, we will add action, and the new
Okay.
implant we will add actioner inside the new implant, because we are working with Oticon and they already have this prototype. Then they send us data, we test with the simulation we are comparing. Really, we are doing the good, we are doing the real application where we test and we see that's what we get. We compare with the real data, and when it's wrong, we say, okay, this is wrong. Maybe it's the limitation of the model, or sometimes the parameters are not good.
But then for the cost root project, what would be the dev to be done? Because
the cost root is really to work on the model, the actual Coursera model, the current Coursera model, to work on that, to ameliorate. I don't know if it's the, but to go to actually, we can't really say that it's in the linear model, but I say to go to non-linear model. Yeah. The model is not related out linear, but yeah, if I can say it shortly, I just to develop something non-linear.
Okay. Thanks.
Okay, I have Alban next. Alban, a few words about your latest and future work with SOFA. Don't play dead, Alban. I know you're here.
What did you say? Je crois le plugin. I said Robin is going to present for I guess both of them. Okay.
Okay. Okay, but still, you still can just say who you are, and because I'm not sure everyone. Yes, yeah, we are with all unknown fellows.
Hello. Can you hear me? Or?
Yeah.
Nice. So I'm Alban, PhD student at Mimesis in Strasbourg, and I'm working with SOFA and neural networks to teach to teach neural networks how objects deform under multiple type of forces. And to do so, with Robin, we developed a plugin that allows us to compute the dataset to train the networks with multiprocessing and stuff like this. So, but he will have a slide, so it will be a bit more precise on the development.
Okay. Waiting for you, Hugo. Give you some time to write the notes.
Perfect. It's okay. It's okay.
Next one, Alex.
Yes. Hi.
Hello.
I have only one slide, so I can share it.
Yeah.
So I'm gonna present my main project at the end of the morning, but this is just to say that I worked with Esther on the mechanical matrix mapper to speed it up. So if you don't know this component, it's used to map matrices from a mapped node to a main node. So this is not supported in SOFA. So we need this component for now. Esther worked on the performances of the matrix project based on a constant matrix structure. So it has been integrated. And there are some other optimizations that has been done. And on the right, you see just an example of the performances that we get. So we have more than a gain of more than 2. So yeah, this is kind of related to the matrix assembly project that I will present in the end of the morning. And by the way, I forgot to introduce myself. I'm Alexandre Bilger, and I'm in the Defrost team at INRIA Lille.
Perfect, thanks.
Thank you, Alex. Again, do not hesitate to open your mic if you want to ask questions, or type them in the chat. I saw a few questions were typed in the chat.
I had some questions for Alban, but we are chatting on directly in the chat.
Yeah. Okay, let's continue our roundtable with Binesh. Are you here? Maybe not.
Yep. Mr. Binesh, can you hear us? Indirect from Iron, I think. If you have any input about what you are doing, what you have been doing, what you are gonna do in the next months, it's most than welcome. Even if it's just forum activity or whatever, it's always good for us. Good to know.
Okay, so we have there is nothing in the chat. Okay, never mind. Camille, a few words.
Yes, hello.
Yes, we can hear you.
You can hear me? Okay.
Yeah.
So, oops, here I am. Okay, yeah. So I'm Camille Créquin from the Defrost team at INRIA Lille. In the past few months, I've worked on the software SIM card test project, which I presented yesterday. It's a European project aiming at proving the usefulness of simulation in replacing clinical trials in terms of cardiac disease treatments, very briefly. So in this context, I've actually worked on using plasticity to model the behavior of pacemaker leads. And this is related to SOFA because for this, I've developed a plasticity model first on the beam adapter, which has not been merged yet to the main branch. So I think it's not been included in the in what you turned public recently. The main issue is that the way plasticity is implemented in the beam adapter at the moment is very unstable. So in parallel to that, I started to try and port this plasticity model on the Coursera plugin, which Ines talked about, and to work with this model instead in order to do the same thing. So basically, each time I implemented a new component, both in the beam adapter plugin and the Coursera plugin, extending. So it's a component that derives from elastic force fields and implementing plasticity. So yeah, in terms of implementation, that's it. And in the beam adapter, I started to implement also tests, so example scenes and unit tests to verify the model. But still, at this moment, I am not able to say what causes the instability I was talking about. And in the Coursera model, at the moment, I only have example scenes, but which allow to showcase what we can do with this, at the moment, simple model of plasticity. So, yeah, I think that's it for my activity.
Can you elaborate on the? You said it was not really stable on beam adapter. I mean, the implementation. It's the way it has been implemented, or is there?
Actually, I don't know exactly where that the instability came from, but what happens is that when dealing with huge deformation causing plastic deformation, the simulation becomes very unstable. The model has tendency to diverge, and I have to, at the moment, I obtain results like by manually tuning typically the plastic parameters and the time steps in the scenes I've been working in. But I think it's revealing that there is something not done properly. Well, actually, there are several factors I think that could explain the instability, but I don't know which one explain it the best, and I haven't tested them yet because then I moved to the COSRA plugin.
When I hear such, is there sometimes is the code sometimes stable and sometimes unstable, or is that relatively unstable?
No, yeah, typically when I have simulation with like one beam or a few beams, then the simulation is pretty stable. But when I try to go into a bit more complex structures, adding like, I don't know, 10, 20 beams and trying to deform them plastically, it can lead to instability. But at the moment, this is very empirical because I only tested on a few scenes, and I haven't really checked on several leads to try and pin where does the problem come from.
And you'll have to implement a specific force field for beam adapter. I mean, a force field for beam adapter, but a specific one for COSRA, right?
Yeah, two force fields basically.
Okay.
The one in beam adapter derives from adaptive beam force field and map, and the one in COSRA derives from the beam hook law force field.
And maybe last question. Yeah, just a remark when I was facing that kind of instability that I could not maybe sometimes explain, can sometimes just be due to the fact there is an error between the force and its derivative. So,
yeah.
And if you have even a small difference between the two, like a factor or whatever, then you'll get your scene to get unstable. But
yeah, I started to check that with there is a component actually in the test in SOFA related to force fields. I don't remember the name of the file, but it's something that implements a lot of tests for force fields basically. And there is one comparing like the derivative of the force computed in at the force, and basically I think a finite difference of the force you compute.
Well, yeah. If you find again the name of the component, I would be really eager to hear about it.
I did some tests with it, so I'll find it and put it in the chat.
Cool. Cool.
I have it under the hand. I just don't remember the name. So I started to try and check the code in beam adapter with that, but I think I've not used it the proper way at the moment. So yeah. There is still work to do, and yeah, the other thing that I didn't said among the leads I have, further the fact that with plasticity we try to model a nonlinear mechanical behavior, but at the moment I only tested this with the free motion animation loop or the basic animation loop, and I believe that means only one Newton-Raphson iteration per time step. So maybe that could come from here. And the other thing is that to deform my beams plastically at the moment, I'm just, I've tested this mostly on stiff materials because I'm used to work with examples from typically catheters or guide wires, like metallic alloys. So it's very thin structures with high Young moduli typically, and I'm applying quite important moments or forces to create plastic deformation. And at the moment, I'm applying them very roughly. So, I mean, probably it could come from that, and applying a more incremental loading would maybe solve part of the instability issues I have. So, yeah. But as I said, this is still to be investigated. And I admit that I put that a bit behind when I switched to the COSRA model.
I have a very generic question. If you could give a grade from, I'd say 1 to 9 to each plugin, where one is it's just a few lines of code in my trash bin, and 9 is industrial, fully tested and perfect code. What would be the grade for Coursera and for Beam Adapter? Yeah, no, it's a very
You're asking tough questions. Actually, I'm not. I think I'm not the best person to talk about both because I'm not very familiar with the whole details of the implementation. So barely I can only speak of well, I started developing a bit, but I really don't have an expertise on all the aspects of the code in both plugins, particularly in the Coursera plugin, which I discovered only a few months ago.
But you're an expert on Coursera. Come on.
Yeah, sure. From the small developing experience I had, it was more easy to work with the Coursera plugin because well, it is more stable, and that the formalism of it is expressed in terms of more or less
It's developed by Younes. You have to
Yeah.
say it.
I forgot to mention that.
Trademark.
No, yeah, but typically as you're dealing with homogeneous strain degrees of freedom, it's way easier to implement a new mechanical behavior in this than in the beam adapter. But then, as formalism is different, it's also a bit more disturbing compared to the rest of SOFA. And really, in terms of code, once again, I'm not the best one to judge this, but I feel that the code hierarchy of Beam Adapter is more complex than the Coursera plugin, probably because it's been developed for much more time. And I don't know. Actually, you did some refactoring on this, and I haven't checked it since the modification.
Actually, you're at a very good place to judge because you're getting your hands in both plugins at the same time. So it's very interesting to have your insight on this, how easy it was, and how well documented they are, and our
yeah. Okay, so I'm gonna rephrase what I said. At the moment, I haven't seen the whole modifications you made very recently in the Beam Adapter, but I would say that Beam Adapter is closer to what you used to find in SOFA. So when you know SOFA, it's easier to implement a scene where you're using the Beam Adapter. One of the drawbacks would be that it's difficult to find documentation about all the possibilities that offers Beam Adapter plugin, because there are many things that are implemented in there that are, well, at least for which I didn't find documentation, but maybe because it was until recently a private plugin. And on the other hand, I think that the Coursera plugin is more, it's more difficult to set up a scene with the Coursera plugin when you're not used to it. But efforts been made recently by Younes to make this easier, and I think it's not far from being used very easily in a scene. And if we go there, then it will be really easy to just set up a scene, use the Coursera Beam, and as I said, very stable in some applications. I think it can be quite easy for a new user to start playing with it.
Okay, cool. Thank you.
I didn't grade, but sorry, I can't.
That's okay. It was the answer I wanted. I wanted to have your insight from someone who is
From my
getting
side, I
his
think
hands.
Coursera is very young. We have few lines of code compared to Beam Adapter. And a while ago, Christian asked Pierre and I to change something. At that time we create a branch. I don't know if it's in the new SOFA you get, because we are removing the control part from the the main plugin, the main component of Beam Adapter. We remove the control part and we just we put the control part inside Python scene. the work Christian asked us to do that a while ago, and yeah, I think maybe I have to see that also to see. And that time we just clean it. We have some, we see some bugs. Well, it's not big bugs, but it's just sometimes in some condition, in some cases, you have the division by 0, the things like that at that time. And at that time also we try to form, to add with what you are doing with SOFA now to say, okay, we are using this principle of SOFA. And what I proposed to Christian at that time is to use transform as they do in SOFA today, but really we didn't finish the work. Maybe we can, I don't know, if we can take it or to clean it again and just add this. This will not change what we already have in Beam adapter, but there's the principal component, which is intervention controller and something like that. We remove this controller part inside the C++ code and we put it in the Python. And this changes a lot of things, like when we have to develop your C.
Do you have an idea of the number of users for
Beam adapter?
Coursera at least, and both if you have an idea.
Coursera, I don't know. Coursera, I only know people who contact me. Then, like I say, we are 5 right now, I think.
Okay.
But Beam adapter, I think minimum.
Yeah,
yeah, I know Beam adapter. Beam adapter is it's huge.
Contact me and we are working directly. Yeah.
Maybe we can switch to Hugo because I know Beam adapter is your baby now.
Yeah, or I got an unwished inheritance in that case. No, just with the help of Fred, we actually cleaned the Beam adapter plugin, like reorganizing the whole code so that it fits actually the format of usual SOFA plugins now. Adding examples, removing a lot of shitty examples because there was actually a bag of them. So there is no more not working examples. That's only working examples plus Python versions of them plus some kind of short, very small Python library that a Python module that allows to build shortly in a few lines a Beam model. But yeah, this is still like a first step. What is definitely missing to make the connection with what said Camille is documentation on Beam adapter. That's what would be missing and that we'll have to work on. But yeah, that's about it. And I don't remember having done much development since last June. So I think that's about it. It was minor cleaning there and there.
Usual stuff.
Yeah, I need to check my GitHub actually, but I think that's about it.
Okay, cool. Maybe Hugo, projection on next month. Do you have an idea of technical stuff for the next month?
Correct. Yeah, maybe for the next step, the next big step we wanna achieve is definitely shit. I forgot my book and my notebook somewhere. It's definitely migrating from the forum format that we have right now towards GitHub discussions, which is the Stack Overflow-like discussion room, so that actually newcomers can actually have a bit in a more easy way access to the developers. So you guys, that people can ask easily questions and get also in a shorter amount of time replies. And having also a nicer interface than our old-fashioned form, which is working fine, but which is really. Thanks for the link, by the way, Camille. I did not see that you were copy pasting the test creation of ForceField. That's cool. So yeah, I think that's the main thing. And I will again I'll check again if some stuff. See if I'm missing some of the points here. Yeah, and maybe one last regarding the training, because we mentioned the training earlier in the presentation, where we should be working early December or within the month of December, maybe across Christmas, on trainings and slides and materials to understand FEM for mechanics and also to make the connection with codes of SOFA. and it would be a good opportunity to then make the connection also with Caribou. So that's something that we would like to have a bit more connection to Caribou, understanding of Caribou, and so that the training also helps people to take this plugin in their own hands.
Okay, thank you. Maybe a bit more. We will go until 10:30 and then have a coffee break. So some people popped on the list.
Could we take some people? I mean, that we hear a bit less. Like I see Sam arrived. Wissam arrived.
Yeah.
I mean, Wissam did not arrive. He was here already, but yeah, I'll let you do.
Yeah. So Sam, I think you have some slides, or maybe not. I'm talking to Sam, but Wissam, it's okay if you're ready.
Sorry.
Yeah, it's okay. It's okay.
So I don't have any slides. I thought that you were talking to me, so
it's all right.
Okay, thank you. Thank you first of all for the organization of this week. I will start by presenting myself. My name is Wissam Awas. I'm an associate professor at the University of Franche-Comté. I do my research at the Think2SC Institute in Besançon. To be honest, I have never used SOFA. I'm here just to discover and to see the advantages of using SOFA. For me, I use SOFA just for one purpose. Maybe one purpose is to do the design, the simulation, and also the real-time control of soft robotics. My main work is about the design and control of soft fluidic robots with multiple degrees of freedom. I'm starting a new thematics about the designing and the control of these fluidic and pneumatic robots. So I have some questions about how to implement and to optimize design of robots by having a lot of constraints and requirements like the number of degrees of freedom and workspace, also the input pressure, in order to obtain the design of a robot. And also, I want also to see if we can use, if we can control dynamically the robot using SOFA.
Thanks a lot for joining, Wissam. That's cool to have you. So I guess you were here as well yesterday, which is more like of a scientific day presentation of what people are actually doing with SOFA. There was a topic and a whole session about soft robotics. And so that you know, today it's really more the technical committee talking about the developments that are gonna take place or that took place in the last 6 months and that will take place in the next 6 months, and discuss a bit those development and see a bit how we could agree in which direction to go with those implementation. Regarding your question, there's actually ongoing work which are pretty similar. I mean, there was several points in your question: the optimization of design, and then the control of a specific robot that you'd like to do. So that's two different parts. But for the first one, there have been work. There is work ongoing on that topic, and mostly what they are doing is that once they have the design, and that was the second part of your question. Once you know what kind of actuation you have, once you know at least a shape of your robot, and that you can actually control the virtual, the digital twin of your robot, actually, so the virtual robot that you have. Then you can include this simulation into an optimization loop, and this optimization loop is usually done either through MATLAB or Python, or actually MATLAB and Python, because you can actually use Python as a bridge between MATLAB and SOFA. But yeah, that's usually the way it works, and you'll be this way. So there is a work, I think Stefan Escaida, who presented yesterday a work on a robot, I would say a robotic actuated prostate for training on some surgical gesture. He's working on optimizing a mesh. So within an optimization loop, you have simulation running, giving you some results, and you have a cost function that you're going to try to minimize. And this cost function and this minimization is made outside SOFA, actually outside from SOFA, within a Python script. And that we could actually definitely put you in contact, because I'm sure you could share some of those scripts without any problem. Okay.
Great. Thank you for.
You're welcome. Yeah,
so I was trying to poke Sam Juanmu. Are you here?
And try to invite him to unmute. Maybe you've already done it, but
no, I didn't.
Sorry.
Hi, Sam.
Hello, Sam. So
hello.
Would you like to speak about you, your latest work in SOFA and your future work in SOFA? I think you wanted to prepare a few slides. I don't know if you did it or not.
Oh, sorry. Yeah. I was planning to, but then because other things, then I didn't make the slide, and also the development is not very smoothly, because I'm currently working on the continuous collision detection. Try to kind of get some algorithms from like previous paper published in the computer graphics, and maybe implement those algorithms then into the SOFA. Try to build up a new continuous collision detection plugin. And so because I'm not purely computer science background, so it takes me a long time to understand the architecture of the source code in SOFA. So yeah. So basically, so the problem so far I met is I have a kind of draft of the plugin, and once I implement and then run it in the SOFA, it's kind of make the simulation very slow. Yeah. So yeah, probably that's those bugs in my code. So I try to debug those.
Yeah, the speed of and especially if it is slow is maybe not a bug, just maybe a question of implementation. But yeah, as Fred said, so continuous. So in the chat, continuous collision detection is cool. It's topics that have been I think already investigated in the past, and I think even there is topics that are restarting a bit, like using implicit surfaces, which is some kind of continuous function for computing the detection of your collision. I don't know if it is the kind of method you'd like to address, but anyway, if you need to have more insight about the API of SOFA, like where should I code that or how this work, never hesitate to let us know. And in the meantime, we could actually investigate who, and maybe some people in the chat could actually say that, who in the past worked on that kind of continuous collision detection method, so that maybe you could restart from something existing and improving it. Okay.
Okay. Thanks. Yeah, I have checked the API of SOFA.
Mm-hmm.
So basically, it's similar to the original plugin, like discrete collision detection, like have the broad face and narrow face. Then yeah, also have my plugin also contain those.
Okay, cool. Really, just to stress that point, do not hesitate to contact us if you're struggling too much with one of those codes, implementation, whatever. Just let us know. Don't stay stuck on that kind of things. I mean, it's really great to have people implementing new methods as you are actually doing here with SOFA. But we know the API is sometimes hard to understand, and that's what you said, it took you some time to go through that. But really stay in contact with us and never hesitate to write us, even not necessarily the forum, but directly per email or through the Gitter, the chat for the developers. Just go there and ask for support if you need. Okay.
Okay. Thank you.
It would be most welcome.
Okay. Yeah. Thank you.
And maybe a last one before the break. I'm taking one in the list. Okay, yeah.
Yes. I work in the Institute of Fundamental Technological Research in Poland. This is a part of Polish Academy of Sciences. And I came here for a short fellowship, 2 months, which I received from your Ministry of Education for 2 months. And I work on evolution of, in fact, of a cancer tissue, and when concerning this the cancer, I use this system which is called PhysiCell, which is an agent-based. This is agent-based system. And I do an attempt to join the results from this system with SOFA. And for SOFA, that's what is very attractive is collisions, just because it's really, as far as I see, and I had this first approach, is very, very promising, because it gives collisions between several objects, many objects, and these objects needn't be rigid. And this is very, very great when comparing with the systems like, for example, this Abacus, LS-DYNA, and the others. With them, you cannot do it, just. But with this, it works. It works nice. The only problem is, in fact, at least in this public domain, public part of SOFA is how to say, for example, there is lack of implementation of this, what I would call composite objects, because let's say we have one object which is elastic, and we have inside this object another part which is in my case, this is, for example, nucleus. Yes, and you cannot change the type of material. This thing is, I think, to be solved just. And a very nice thing which is done recently is the shells which are necessary for the cortex of the cell, and the cortex which is around the nucleus, and so on and so on. So just these things could be nicely improved, and I'm attempting to learn these things and to have them. Maybe only one slide, if you have a bit time, just. And I will try to share the.
Maybe at the end of the roundtable,
okay.
we will see if we have some time.
Yes, sure, of course. So thank you. This is it.
And I think maybe just to add one last thing about Elijah's work, it's that you're currently interested in extracting, for instance, I mean, that was the last discussion we had, extracting strain and stress tensors from the open source FEM codes of SOFA, which is by default not really easy. I mean, not made for that. So we were discussing about the Caribou plugin or implementing directly extraction from SOFA. So
Yes, exactly. Thank you.
Thank you, Eligius. So I propose to make a small break, maybe 15 minutes, maybe 15-minute break. So I have a very nice countdown here.
And maybe in the meantime, so do not hesitate to use the chat if you want to ask questions, or if you'd like to talk about something right after, like because of time constraints or whatever, you want to take the mic right after the break. Let us know in the chat. Otherwise, we're gonna give you the mic one by one as we did.
I'm just gonna grab a coffee and I'm right here after that. Okay, guys, I hope you are all back. We will continue our roundtable, maybe a bit quicker. I will take the opportunity to just open this second round. For those who don't know me, I'm Guillaume Parent. I'm working with Hugo and Fred in the consortium. I'm dedicated to all the environment stuff around SOFA and around the project. Everything around release management, continuous integration, GitHub, the forum, and all the things that gravitate around the project. So if you have questions about this type of things, you can poke me. In the last 6 months, I worked a lot around the next steps of our continuous integration workflow in SOFA and in the plugins. So you should know now that we have a big continuous integration for SOFA that is testing all the pull requests, that is testing all the release, generating the release, making tests, making regression tests and everything. So you know that pretty well. There is a dashboard and everything. We try to keep it green, but it's hard, and you know the drill. So this is for SOFA, but now we are going into the next step, which is we do not want anymore to just keep have nice things for SOFA, but also to provide the same nice things for the plugins maintainers and their plugins. So that's what I worked on for the last 6 months, and I will present it to you a bit more in details after with slides and everything. But this was my main topic. So bringing the magic of all the things that we already do in SOFA into the plugins for the plugins maintainer, because we have more and more plugins that are out of SOFA, because that's the policy that we want to apply now, having the plugin out of SOFA. For the future, next 6 months, I will continue this work, try to present it to the teams and to help the teams understand everything that I did and what they have to do to apply these tools. And I'd like also, and this is a subject, a topic for tomorrow, I guess. I'd like to really get into the deprecating things, the deprecation mechanisms in SOFA. So it's something that I worked a bit on in the last 6 months, trying to make things clear about how we deprecate stuff in SOFA. So what can be deprecated? There is a lot of stuff that can be deprecated, and for each thing, how do we deprecate it? And how do we keep consistent all the mechanisms for deprecation? This is the big challenge. So this is something I'd like to work on the next 6 months, and that we will discuss if you want to join tomorrow. I guess there is a slot for this. That's it for me, and I will give the mic to the next one I see, Alexandre Teixeira. Are you here?
Alexandre was here a few minutes ago.
Alexandre, if you're not here, I'm skipping to the next.
Go ahead.
Ansari, can you speak, because I see that you are on your phone?
And again, do not hesitate to, if you cannot speak or whatever, do not hesitate to at least write us later on in the chat. But the best is to unmute. But obviously, if you'd like to just write what you are doing, what you are struggling with, and what you will work on later on, it's most welcome in the chat now.
I continue my list. Arnaud Mazier.
Yes. Can you hear me?
Yep.
Yeah, salut Arnaud.
Sorry, just coming out of the dentist, and I'm in the train. Like I presented yesterday, so my who I am first. So I'm Arnaud Mazier. I'm a PhD student at the University of Luxembourg. So I'm currently I worked a lot with the companion otoscope that a lot of you already know. I mainly targeted soft tissue simulation, mainly on the breast. But now I'm working on something different with Jack Hale at the University of Luxembourg. We work on coupling Phoenix with SOFA. So if you weren't here yesterday, Phoenix aims at giving automatic differentiation tools that can output C code, and I read it with a C++ code. Sorry, I'm out of breath. And so that's what I worked during the past 3 months. So I just obtained first results to mimic the Saint-Venant-Kirchhoff material. And so now my aim in the next following 6 months is to try more complicated material law, and also try different elements such as hexahedron with a different interpolation order. Oh, thank you.
Perfect.
Thank you, Arnaud. So if you have questions, guys, do not hesitate to open your mic or to type in the chat. And I will continue my list with Damien.
Me?
Yep.
Okay. In the next 6 months, I will probably, so I am Damien Marchal. I am working for the CNRS in Lille, and also with the Defrost team. In the next 6 months, I will probably be involved into the setting up of the T-Rex project that Christian Durier told you about. And also on restoring our plugins to work more smoothly with the next SOFA release. What I did previously, and I hope I will have time to continue, is that we work on with Nicolas Zotto. I saw it was there yesterday. I don't know if it's here today, but we work on collision detection for implicit surfaces, between implicit surfaces on a GPU for precise contact modeling, basically without triangulated or tetrahedralized topology. And let's say for open as an open topic, I am interested in design and optimization of shapes that we work in the past with Thomas Morzadek. So optimizing shape of soft robots. And also I have some interest with the Phoenix plugin or code generation aspects related to SOFA. But I have no roadmap for that.
So maybe Sam, you see, you could actually connect maybe. So you see it's the topic of, we just mentioned continuous collision detection before. Here we are hearing about implicit surfaces used for collision detection. It's one topic which is pretty similar to yours. And then what was the second one? And
shape optimization.
And shape optimization.
Of shape or yeah.
Yeah, and this topic was very close to, and said that earlier. I'm sorry. I'm looking in my list. Wissam, yes, from Femto ST, which is not here anymore. But there was a professor from Femto ST interested in that part here. So
yep.
I'm gonna point that here. Okay, thanks. Maybe another a question about what you're gonna do is the topic of discussion that we set up. I'm looking for the exact name of the session. Yeah, do you think everything about internal state of component and get contact and links and so on is going to be an active topic for you, Damien, or not? Or it's not really something you'll have on the road that you're actually working through?
Yeah, but I see this as a transversal issue for SOFA, and with so I think it's an important issue, and I would like to there is some advances, but I think it's a collective one. It's not something that I could handle in my own plugin and deliver something to my community of users, which are soft roboticists. So I will not handle that as my core activity. Because basically it's very hard to deliver something with a lot of usability. Not sure it was clear. But
yeah, is there any other like transversal topic that as this one you'd like to address?
But let's say the underlying issue is more usability. Actually, is basically insofar I consider that the lack of formalism in how component update their internal state and expose it has consequences on usability of SOFA, because basically if you want to know what will happen when you call init, reinit, or some function, you need to just learn learn it by the documentation or by trial and error and SOFA crashing. That way, actually, you cannot use the component that way. And so I would, to me, this is something, because yeah, Christian want us to do that SOFA simulation should be doable by people that are not developers. This means those guys need to be able to understand very quickly how to make a scene that will not crash and that will behave the way they expect. And this means to have some kind of consistency in terms of behavior for any component that is used in the scene. And actually, as it was not formalized currently in SOFA, the consequence is that every component do the way it wants or the way its developers want it to, and which make it very hard for newcomers to know. And basically, I am often people show us scenes that make sense, and the only answers we can give them is, yeah, okay, your scene is perfectly makes sense, but because the way this component is implemented, you need to refactor your scene to make it work, or to make not it crash. And I think it's an issue for us.
Yeah. But, all right.
So
okay,
just to remind that this subject will be discussed tomorrow. Should be discussed tomorrow at 11. Maybe it will move, but I guess it won't. Okay. Another question? Did you have another question, Hugo, for Damien?
Nope.
Cool. Next one after Damien was Ifrain. I think you already talked. Ifrain? Sure. Sorry if you already talked.
No.
No, you didn't. Are you here, Ifrain? Ifrain Albor?
I'm suggesting to unmute if you like, Efrain. It would be cool to have an update on your end.
You're asking for unmute, Hugo?
Yeah, I just
every time.
Okay. Sometimes. I mean, when
okay. Because I'm not doing it, so I let you do it.
Yeah.
Okay, cool. So maybe we will skip a frame. François? Oh,
Yep.
sorry, Eric. Eric, I skipped you, but we will come back to you after. Sorry.
All right. Yeah, can I carry on?
Yeah, yeah.
I'm François Jean. I'm working at Insimo, and I'm taking care of, well, part of my time I take care of the research activities that can be interesting, like for the company. And I would say, like in the past 6 months or past year, like we released our open source fork of SOFA that we're using at Insimo, which implements I would say, like natively multi-threading. So it was we made a small test example which demonstrates how we use multi-threading in our code base at Insimo. I'm also interested, like, in linear algebra, and you had a presentation about that by Philippe Pinson yesterday about how to, I would say, do smart updates on your Koleski factorization so that you don't do the full factorization at each time step of your simulation. And I would say, like, in the future, I would be interested in bringing more, I would say, solving strategies and algorithms which were developed by various research teams, particularly like at INRIA, the team like which is currently led by Florence Berthays, if you know her. And so that, yeah, I think it could be interested also, like, in the field like of robotics, because currently we are using a solving strategy. There's only one which is available in SOFA, which is called the projected Gauss-Seidel, to solve hard constraints. And actually, I wouldn't say that it's no longer state of the art, but there are, I would say, many different methods that exist and that have been developed to address this type of hard constraints problem, and which could be also interested to investigate, like for other applications compared to just soft bodies in contact. So yeah, that's something I would like to push forward, like for SOFA in the next 6 months. Yeah, but I'm also, like, of course, like, there's I'm involved in several research proposal, like that we submitted, like, recently, involving also, like, the team of Defrost at INRIA Lille, but also, like, other research teams in Europe, particularly in Copenhagen and in Madrid. And depending on the acceptance of these proposals, it could also bring some, I would say, like, more activity or more research algorithm available, like, in SOFA. So yeah, that's it.
Cool, thanks. Do you know when is the deadline for acceptance?
I would say next year. There is one which is I would say, like, a very difficult, like, grant to get, which is a Horizon European grants, I think, which have a very high rejection criteria. But the other one is which I think will pass for sure. I mean, there's quite a large chance that it will pass. It's for to finance, like, doctoral contracts, so for PhD students.
Okay, and is that already in connection with some of the institutes you mentioned for this one?
Yeah, one is with collaboration with Lille. It's and it will be, if it passes, it will be led by Insimo. So
okay.
We'll have, like, the PhD student, like, for 2 years and 1 year at Lille, and it's to develop, I would say, like, new solving strategies, like for the contact. So it's basically a little bit like what Christian and Damien, I think, mentioned. the fact that if you have like smooth surfaces, or you can derive like more, I would say, like complex contact equations, which take advantage of the fact that you have a continuous surface. And the idea is to have a more accurate contact formulation thanks to that. Because one of the, I would say, like one of the problems you have, like with when you solve contacts, is sometimes like because of inaccuracies in the solution. Sometimes you want, I would say, like the two surfaces that are in collision are not well separated by the I would say, like the constraints resolution algorithm. And the idea would be like to provide like a better accuracy, not necessarily in that particular context, but in general, a better accuracy to this sort of contact geometry. And yeah, the other one, it's with the University of Juan Carlos. It's led by Miguel Otadui. And it's mostly to bring like a new formulation which can be useful, like if you, when you, for instance, like do a needle insertion, or when you have like an endoscope in a cavity, it's to develop like methods which are called Eulerian and Lagrangian. So it's a different formulation of, I would say, like a persistent contact between two objects. So that you don't suffer like from a discretization artifact that you typically get with, I would say, a standard Lagrangian formulation for contact. So that's the two research topics that we try to push forward, like for with this project.
Okay, cool. Okay, thanks a lot, François. Yeah, and Alexandre. So first, thank you, Alexandre, for specifying everything. So Alexandre in the chat is a PhD student working with Florence. That's why I'm making the bridge between what you just said, François, and Alexandre. I think it would be really good. It would be really cool to have a discussion time sometime with Florence. But actually, when I say sometime, it would be not as soon as possible, but soon, so that we could make some updates about what. What could be possible, what if she would be interested in pushing some of those topics here. Have you, François, talked recently with Florence? Or
No, not recently. I wanted like to reach back again, like with some, I would say, like concrete stuff, because the idea for me would be like to find a way to get some money for an engineer to do this sort of transfer. And I think there's also like some interest, as far as I understood, like on our side, to I would say, like to have like I would say how to say that, like the formalism that is brought by SOFA, like to express basically how you define a contact point on an arbitrary geometry, which he hasn't got like in our own code base, I would say, like naturally. So it would be, I think she was interested in having that like out of the box to do more experiments. So so I think that could be also interest on our side, like to have I would say, like the models, because like here I'm talking about the I would say, like the rod model that she developed, like the 1D rod model, which is close to a Cosra actually, and to have it integrated in a more, I would say, comprehensive simulations to test more interactions, more all the capabilities like of this model, and see whether or not it's suitable for other, I would say, other scenarios than the one that she initially anticipated.
Okay, thanks. a lot of topics. And one last comment, and then I'll shut up for going to the next ones. But it makes the link with also what Alexandre did. So Alexandre Budget, what Alex did more recently, like in the first half of 2021. You mentioned multi-threading, so there have been some implementation proposed in SOFA, but I think it's still like really for SOFA an ongoing topic where we did not at all exploit everything that you actually shared in your fork, François, and it would be, I mean, that's taking one guy, I think, working on that at least for a certain amount of time dedicated on that topic to update SOFA for multi-threading, but I think it's not really on the agenda for the moment. But I mean, there is no dedicated engineer, and that was not really the topic of Alex originally. So just I wanted to say that. But if someone is interested in multi-threading, I think there is a lot of things to actually benefit from using what Insimo already proposed.
I think there is a breakout room dedicated to multi-threading, right?
Okay, sorry. Maybe I might have missed it. Yeah, you're right. First one.
Yeah, tomorrow 9:30.
Yeah.
Okay.
Thanks.
Thank you, François. Next one on my list, we will try to be a bit quicker. Martin Strunz.
Mr. Madin.
Are you with us? Yes, I see you unmuted, but we can't hear you.
Yeah,
I don't know if you're talking. Maybe you have a small configuration problem.
With the right arrow.
We can't hear you. Oh.
I have some echo as well.
Yes, we can hear a little bit.
I can't. Maybe it's because I'm a bit deaf, but
maybe try to configure and come again. I will come at you again, and I'll skip you for now. Next one is Maxime Tournier.
Can you hear me?
Yes.
Fine and clear.
Hi everyone.
Hi.
So I'm Maxime Tournier. I work at Anatoscope. Some of you may already know me. I'm in charge of our own SOFA fork that we manage. We've been managing for the last maybe 5 years or so. So as you may expect, our fork diverged significantly from the usual, the regular open source SOFA version. Yeah. And what I've been doing for the last months is basically related to what Damien has been mentioning in his during the roundtable. It's related to the fact that it's really difficult to analyze for newcomers what's going on large and complex SOFA scenes. And so we've been actually removing the whole init system for Python because it's really confusing. It's hard to compose large scenes.
What do you mean by removing the init system exactly?
There is no init whatsoever. At least
it's automatically done, or okay.
Exactly. Yeah. When you instantiate a class from the Python side, then the class is automatically initialized, and you don't have to deal with the asynchrony of backward init and stuff. So everything is initialized synchronously as soon as you instantiate the components from the Python side. And it was quite a ride actually to to implement this change. It was very difficult to do, and it took us several months to get there. But now we're really happy with this. Something else I've been working on is to annotate all the Python code we have and the Python APIs with MyPy type signatures. And actually, we do use MyPy, the type checker, for Python quite a lot, and we've been relying on it more and more because it's impossible to manage unit testing without at least some form of static analysis. at least in our code base, it's really difficult to get the perfect coverage. So in the meantime, we really have to rely on a static analysis tool like MyPy to do refactoring, for instance, on the Python code. And we do have a lot of Python code. Another line of work is to anticipate the unified metrics assembly we've been discussing in the past SOFA STCs. And to do that, I've been merging all different metric mapping classes to get all of them under a single basis. So there is no longer like mapping, multi-mapping, multi-two mappings and stuff. It's just a single mapping implementation class. So it's easier to change the interface after that. So it's mostly bookkeeping, but still it was difficult. And I'm in the process of removing the visual models because we have this, it's annoying to have non-mechanical mappings. And we would like to have the visual models to be engines instead, or at least to act as engines, so that we have mappings on one side and really everything, all the rest is handled by the engine mechanism. It's all, again, it's related to what Damien mentions, like it's difficult to have to analyze all the SOFA components except for the engines that are somehow pure mathematical functions, like side effect trees, mathematical functions, and these ones are really easy to work with, and we have large engine pipelines, and actually we're going more and more to our aim is to enginize almost everything in SOFA so that the dependency graph is correct, and we don't have to deal with side effects anymore. And so, yeah, in our fork, engines are or must be side effect free, and we use them quite a lot. And so this is for why we would like to have the visual mappings, visual models to be engines as well. Maybe one day we'll have mappings to be engines as well, but it's not there yet. Okay.
Very interesting. Thank you. So Daniel reacting a lot in the chat.
I have a question about what that change when you use map engine instead of mapping for the visual part.
So mostly you have position and normals linked on the ones that are in, for example, on the degrees of freedom. But you don't have to have, so we map the position using engines. For example, you have a rigid engine or a barycentric engine and so on. So there is a tiny bit of duplication between the mappings and the engines, but at the same time, it's it's more convenient for us to remove the visual mappings, because it's hard to get dependency right with the mapping system. The mapping system is a push-based dependency graph where you have the visitors that push the modifications, the changes in the graph, whereas the engine and the data graph, the dependency graph, is a pull-based. So it's way easier to get something that's up to date for rendering, for instance. So that's why we would like to move to a pull-based dependency management for visual models.
Okay, but in that case, if you have like you are using something for the visualization, an external object for the visualization, what that change?
Sorry,
if you are using like an external object like a Blender or something like that for your visualization part, when you are using engine and when we are using mapping.
You mean the rendering engine or something? Yeah, we have actually two rendering backends that are homemade. It's Olivier Carré that used to work on that has designed a Qt asynchronous rendering engine. It used to be like based on Qt 3D, but we had lots of problems with it, and now it's a custom OpenGL based renderer, and we did also have a Unity-based renderer backend, I think. And so these are using a engine mechanism. And we are now in the process of completely removing visual models from our fork of SOFA, so that we don't have non-mechanical mappings. We only deal with mechanical mappings.
Thank you.
I have one question, or
yeah, sure.
someone. Yeah, do you plan like to sort of release like what is open source, like in your version of SOFA, or?
Sure, it's open source. I mean, it's LGPL, so we have to. It's accessible, I think, on our website somewhere.
Okay, so I was checking only the GitHub of Anatoscope, so that's why
it's
I was.
Not on the GitHub. It should be on the GitLab instead. But yeah, sure. I think it's accessible somewhere. I will ask Mathieu about it if it's not, because it should be.
Okay, no, it's just I'm always interested in scanning like a code base, so to see.
Sure. I will make sure it's accessible. I mean, it's not hidden somewhere.
Okay. Cool.
We do have a lot of Git repos. It's a bit of a pain to crawl because we've been making dozens of repos for every plugin we've been developing. But some of them are still open source, and some of them, these all should be accessible. I will make sure it is.
Cool. Yeah, and yeah, I don't know what you mean, Younes, here by your point, but definitely I would be interesting. If interested as well to just have access to it, and so that a bit like for the multi-threading topic, if we can improve and follow what based on what you are actually doing, it's always a lot of time saved.
Sure.
I posted something. I just wanted to know if it was correct, Damien. This system of moving everything with a like tool-based approach from the engine sounds like really close to what we are actually doing. Just because using the callback, we are setting up a callback mechanism, which is actually using a tracker, and exactly in the same philosophy, like a lazy update, but just not going through engine, but you have indeed internally now you can actually have now internally within the components the way to update them following the mechanism of the mapping. So I think it's pretty similar, just a different way of doing it. Is that correct? So I don't know, that Damien, your opinion, or Maxime, if I was clear enough in what I said.
Yeah, I think it's exactly the same philosophy. Basically,
Okay.
everything should be visible and materialized into the data dependency graph. And so what you are referring to is part of that, in which we want to make the internal state of object that pre-computes things and have side effect to also be visible into this dependency graph. While I think an engine is not supposed to have a side effect, it's only supposed to process data in and out. So okay. The only difference between classical components, which are designed to work with the data tracking mechanism, and engine is, to me, there is side effect in one and not in the other. But I think it's maybe just a very small detail. But the general philosophy is the same.
But it's really fun to see, indeed, and that's what you said in the chat, to see the parallel, I would say, motions of what we are doing. That's here on the engine-like mechanism, and so we did not know. I did not know about the MyPy project. It's something we're gonna definitely have a look at, and for the also the removal of the init in Python. So that was something pushed a lot by Damien. I remember being a bit not skeptical, but I did not really understand the point at the beginning. And indeed, yeah, it makes definitely sense. So, and it's funny to see that.
But from what I understood from Maxime is that they removed the init from SOFA.
Yeah.
Python side mostly. It's
okay.
Still available, like deep down, but it's not really accessible. I mean, most of our code is done on the Python side nowadays. I mean, it's been like this for a long time, and so we wanted to remove completely the init from the view of our developers, because it's really confusing. It's hard to compose, it's mostly about like composability. We have such huge
I fully agree.
code base. It's we have to be able to reason locally about the code. So init is difficult because you get long distance side effects. And also engines are great because you can reason locally about the engine. It's say, okay, if there's a problem, garbage in, garbage out, you know exactly. It's easy to decompose the problem to say, okay, pinpoint the problem where the exact location where the problem comes from. And that's critical for us. I mean, we've been putting a lot of effort in these changes.
Thanks. It was very interesting to have your view on that.
Thanks.
Again, do not hesitate to set a slot for tomorrow or Friday if you want to discuss more into details about all this. I'm pretty sure that there is a lot of interest from several people here on this. We should stop now, but we will have I guess 2-3 more people. I'd like to test if Martin, your mic is working or not. We still can't hear you. I see that you are unmuted, but we can't hear you, unfortunately. So maybe just type in the chat so what you did in the last 6 months and what you plan to do in the next 6 months, and we will add it to the report.
Especially the second part, the activity in the next 6 months, because for those who do not know Martin has been around in the project, like spotting small issues around SOFA, pointing really on the GitHub, running some script and detecting some errors in the code, which is always nice, and then making pull requests. So thanks again, Martin, for getting involved in the project.
I also see Mladen that just arrived. Could you have a few words, Mladen, about your latest work and future? I see no unmuting. Or we will skip to Team Push.
Hi, Tim.
Tim, are you with us?
Yeah, I'm with you. Can you hear me?
Yeah,
yes.
Perfectly fine.
Okay, perfect. So my name is Tim. I work at the Fraunhofer Institute IPA. We are located in Mannheim, and our group is mainly working in the context of medical robotics and also sensor development. And currently we have 2 projects in which we use SOFA, and one of them is in the field of catheter interventions. I think some of you will probably know about this project. Our main goal is to develop an autonomous controller using reinforcement learning. And the role of SOFA is basically to allow us to generate synthetic training data for this controller. So we couple SOFA with our reinforcement learning framework, and then run thousands of simulations to train our controller. And then the second project, which actually ended in summer, in that project we were modeling a fluidic actuator, a soft fluidic actuator, and we're mostly using the soft robotics plugin. And the goal for us was to first to compare SOFA simulations with ANSYS. And so, yeah, I guess the main goal was to eventually be able to integrate SOFA into a design optimization loop. And yeah, but like I said, this project unfortunately ended in summer, and currently we're looking for new grants and new ways to incorporate SOFA into our projects.
Tim, about that, so about the fluidic actuator, is that are you looking for also some people to work on the topic, like new profiles, or is that it was just an investigation you ended it here, and yeah?
So currently the project is on hold, or this entire topic is on hold, and I also do have to say that we so our management changed a few months ago. So currently we are reassessing our focus, our strategy, and so it's a bit hard to say at this point if we will continue in this field. So in the field of fluidic actuation and fluidic robots.
Yeah. Okay. If you need again anything regarding project writing or whatever, description documents that you would need for this new direction. I mean, I know how it is when directions are actually changing. So if you need anything to just justify anything, just let me know. I would be happy to help.
Thank you.
And what? Yeah.
Maybe just in general, we're always looking for other research teams to collaborate with. I know we've had a few attempts to set up projects and to work together with team in Strasbourg and Lille. So far, unfortunately, it hasn't worked out. But if any of you are interested in collaborating with us, or if you need a German project partner, then you're always happy to. We'd be happy to collaborate with you and work together with you. And just so you know just to give you a brief overview of what we are working on, I'm going to post our website in the chat, so you can have a look at our projects and what our main goals are.
Cool, thanks. I think, for instance, in the list, there would be we could actually hear shortly because she just started, Valentina, but you'll see it's on very similar topics. Maybe it could be a topic of collaboration that could be to be discussed with Stefan and Valentina later on. But that's she will explain a bit her topic of PhD. But yeah, definitely I can only advise to go for a collaboration with Fraunhofer. It has always been successful and working smoothly in the past. So if you're looking for partners in the field of robotics, or and even so reinforcement learning for your robots and so on, that's something that could be done. We could even, he's not here anymore, but we could also connect to Adrien Courtecuisse, who is so quite close on the other side of the border to see if he could have some also projects to share and to include you with, or at least to set up together. Okay.
Yeah. Thank you.
And do you have some so you noticed that BeamAdapter got released? So please, any feedback about that? So with LGPL license, as we already discussed before together, team. If there is any feedback or anything that you need or you'd like to add, please go ahead. We'd be happy to.
Yeah. Thank you. Yeah, I haven't had the chance to look at the code yet, but I'm very happy that it was open sourced.
Cool.
It will save us a lot of hassle.
Valentina, can you make us maybe I see, I mean, in the document we are having, you're just next in the list, and it relates well to the discussion we had with the team. Could you just give a short update and presentation of yourself as well? So I cannot hear you. I see you're unmuted, but I cannot hear you for the moment. Maybe again we've got the problem before that, for instance, with Safari stuff it was not working. So maybe make sure, I don't know, or just setting of mics. See, Stefan is back. Okay. So do not hesitate to type in the chat. But yeah.
In the meantime, I guess Stefan wanted to speak a bit.
But
Stefan, if you want to react.
He's unmuted, but I cannot hear Stefan either. So I see you are unmuted, but
yeah, Stefan is.
So the platform definitely seems to be reluctant to a certain number of browsers. Definitely. I'm sorry for that. Sorry, Valentina. Sorry, Stefan.
It's weird. Okay.
Yeah. So yeah, if you're on Firefox and if you have Chrome, maybe the best would be to try Chrome or Chromium or similar.
Yeah. Anyway, just try the other browser that you have, just to make sure that all the authorization are set correctly.
Yeah, I'll let you continue with Olivier, maybe Robin.
Yeah. In the meantime, Olivier, or maybe Robin is more related to what we just said before.
Yes.
Robin,
Yes.
a few words.
Yes, I'm here. So I won't go through details because I will have a presentation in a few minutes. But yes, I'm the guy involved in the development of DeepPhysics, which is a Python framework aiming at interfacing AI with simulation. So our case so far. And yeah, I've been involved in developing this framework.
So, that's typically you mentioned RL, reinforcement learning. So it's not. I think it's not something that has been widely, for the moment, applied using this AI platform developed by Robin. But it could be. I mean, could be something that could become like a common platform, common framework. I was thinking about you, Tim. Tim, you mentioned the RL framework that you developed on your own. What was it? Was that a Python-based platform or?
Yes, it is. It's Python-based. It's based on PyTorch. Yeah.
Okay. So I think that's also one of the libraries that is actually compatible with DeepPhysics. So that could be interesting to, if you would like to discuss a bit further with Robin and to like to see where it's actually going for them with so just the name, so that you might have seen that already in the slides, but that's the name of the project, DeepPhysics. So that's
of course, yes.
Okay, thanks, Robin. And so there will be a dedicated presentation right after.
Stéphane, did you manage to unlock yourself?
Is that working better now?
Yes.
Oh,
yes.
That's yeah. So I switched to Firefox. So I missed a few minutes when I clicked on the link that you sent, Tim, about the activities in your group. But I just wanted to say that now we have a PhD student who arrived a couple of months ago, Valentina, who I'm sure he's following the discussion. And she will be also working on, I would say, some version of control, autonomous navigation of catheters. And so the part I missed, because on your website, you still have videos of this work. And I was wondering if you are still active on that topic and what's the status. And maybe, this would be one example of things we could collaborate on.
Okay, so question is if we are still active in the field of autonomous catheter control, correct?
Yeah, things like that. Yeah.
Yes, we are.
Okay, cool.
We are, as usual, always looking for funding, and currently, some of our projects related to the control of catheters has ended, and so, like I said, I mentioned earlier that our management changed. So currently, it's very hard to say in what specific direction we're going to push this. But we are definitely still active in this field and very much interested in continuing to work on these topics.
Okay, so maybe we could, I mean, there are obviously several aspects on which we could at least discuss, and that's what I would propose. Maybe, right at the beginning of next year, when Valentina starts to have a few results, we could discuss about what we're doing on our approach, and then the next part relates directly to what Robin will talk about, which is this idea of trying to incorporate or to couple links simulation and machine learning, which I would say brings some challenges, okay, in terms of not so much how to, because the typical thing, if I want to make it short, is lots of people are using, you know, simulation to generate data that is then used to train the neural network. But what we found out is, you know, for instance, we can reach much better levels of training and predictions by, you know, leveraging things directly from the physics, like knowing the energy, internal forces, things like that. But accessing this information, for instance, is a lot more difficult when you have two quite different frameworks that want to talk to each other. Yeah. So, you know, I have a thing that as we will, not just us, but the community keep pushing in this direction, some new challenges and maybe new ideas will come up, and maybe this is also like a more general topic to maybe discuss. And I think some of our ideas will be presented by Robin, but after that, maybe we can keep on discussing on that more generic aspect.
Yeah, and again, as this subject is and will be in the 22.6 roadmap, it will be rediscussed this afternoon. So there will be plenty of time between this afternoon and maybe the days after if you have availability.
Perfect.
Okay, so I guess we'll, sorry for the others that were waiting their turn, but I guess we will have to continue and to stop the roundtable here. I'm just pasting the link if I have it somewhere here.
I mean, yeah, we only have here, you know, Olivier and Sidati to go through. Would you mind like taking just a few minutes for each of them? Just like
if you have if you can just take 10 seconds, yes, you can. But anyways, I'm pasting the link, so if you want to join the notes and directly type into the notes your report, it will be also very nice for us.
Oh, ciao, Olivier.
Go ahead, Olivier.
No, yeah, maybe I can just say we had funding for, so we have an artist that's doing a residence in our lab since September and until January, and he's doing he's a folding artist, so he's doing origami, and he wants to animate an origami. So I'm as a part of this, I'm developing a small plugin to simulate origami in Sofa. So I created a very tiny plugin for now.
Folding structure sounds much better.
What did I say?
Folding
what?
structure. I don't know.
Yeah,
structure you can fold.
Yeah, because what did I say?
Origami.
Okay.
It's
so it will be open source?
Yeah. Cool. It will be buggy and open source.
As always.
Welcome, Sofa.
Okay, thank you. Sidati, a few words?
Can I just ask something to Olivier, because there is a topic of super high interest that I won't say I'm not sharing about it anymore, but I did not see. So there is things, I guess, happening. But what about constraints or the two, Olivier? You know, you mentioned that.
Yeah. So
I was super excited about that.
Back to it in the next 6 months, indeed.
You will or you won't?
I want to.
You want to? Okay, cool, great.
Yeah, because it's almost we haven't. It's not completely satisfying at the moment, but yeah, I don't want to give up on it. So.
Okay, cool. And if you have so I put the page of Dewi Brunet. That's the name of the artist. And if you have a better page to share about what you did together, you know, with the inflating origami robots, that would be super cool.
Yeah, we will have some, because he has to do a first demonstration tomorrow, actually.
Okay,
so.
cool. Ah, yes, cool. And go ahead, Sidati. Sorry, you are ready to go.
It's okay. Can you hear me?
Perfectly fine. Yeah.
Okay. I am Sidati. I'm a PhD student at the Menezes team in Strasbourg, in Ria, supervised by Stéphane Cotin. So for the last 6 months, I've been working on doing a simulation of the vascularized liver using Caribou plugin. And then I've also worked on some validation stuff, comparing some simulation from SOFA and DeFi-Bio, and also using some manufactured solutions. So for the next 6 months, I'll be working, I guess, on making or improving the surface registration, so using neural networks and trying to predict the deformation of the liver, using what have been also already done in the team and trying to improve that. I'll be also very interested in collaborating with Arno around the combination of Phoenix and SOFA. So I guess that's all.
And I think also Arno, using this SOFA and Phoenix bridge, I think he would be interested also to work with you on the aspect of, getting validation scenes, and that was a topic a bit yesterday for validating the models, having scenes by default that you could actually run, and so that's really, really nice.
Yes, that will be very cool. I have a kind of pipeline that aims to compare two simulation, one based on Caribou and another one based on FI-Bio. So, and also I'm exploring some called manufactured solution, which is a kind of analytical validation of code.
I was more thinking about this second part, actually, that would mostly interest Arno. Arno would be, I think, super interested in that.
Okay. All right.
Can I say one quick thing? I know we're maybe running out of time, but super quick. It's that I think Caribou now is showing that it can be both linked with Phoenix. We can introduce validation in it. Yeah, I think it's a very interesting basis for a better way of doing FEM in SOFA. But we have one relatively big issue. Is that when Jean-Nicolas developed it, he only considered, I would say, problems where you only have 3 degrees of freedom per node, and we've looked at how to integrate models like Beam, Costrat rods, and others in Caribou without much success, because most of these formulations, they either require 6 degrees of freedom, or you have 3, but they are not the same as the usual XYZ spatial coordinates. So if Inusa or others who are working on this type of models are interested in at least investigating the ability to have these models also part of Caribou, I think this would be a nice way of having one sort of unique space for these new advanced FEM models. But probably not this time, but maybe later.
So as you wish, because so that's actually the reason why we set up, because first we know that it's going to be something that will evolve on Camille and Younes side for Beam and Costra plugins. But so since we know it was going to evolve, we saved a bit of time for today to discuss that. And actually, I think there won't be much discussion about what they are going to do, because they know what they're going to do. They already explained that earlier. But I thought it could be interesting to save a bit of time about beams today, since it's going to be on the roadmap, because they're working on it, so that maybe Stéphane, Sidati, and with Younes and Camille, you could actually discuss this specific topic. That's why I kept it, I was suggesting this beam, in general, beam topic for this afternoon. So if you'd like.
Yes, certainly. What time would it be?
I think it would be more or less the third topic of the afternoon. So it would be, if I'm correct.
Yes.
So yeah, I don't have the planning under
around two.
Okay, I'll be there then. If you guys can make it, yeah, let's talk about that. I think that's an important one.
Mm-hmm. Cool.
Okay, so again, for the ones who did not speak, there is the link for the notes. I paste it again here. So do not hesitate to join the notes and to complete your part directly in the notes, so that we will have them for the report at the end. So I'd like to move on now for the next part of our morning, and actually the last for the morning. It is the review of the progress that has been made for the 2112 release. The 2112 roadmap was quite large. We had 6 projects in it. So SOFA NG, topology, matrix assembly, user dev experience, SOFA and AI, and Coursera. So there will be a presentation for each one to show you what has been done during the last 6 months. So shall we start with matrix assembly, Alex?
Yes, sure. Trying to share my screen. Here we go. Can you see it? Can you hear me?
Yep.
All right, so 10 minutes, right?
Yep.
Okay, just a brief introduction on what matrix assembly is. So when you use a time integration scheme, you build a linear system at each time step, and you need to solve it. So you have two kind of linear solver for that. One type is matrix-free, usually iterative methods such as the conjugate gradient, and you also have matrix-based linear solver. Here we built explicitly the matrix or something that stores a matrix like data structure. In this matrix, basically, some components contribute to add values in this matrix. And such components are the force field, the mass, and the constraints, etc. This is the matrix assembly introduction. So we came up with the idea of refactoring this part in SOFA due to some limitations. I won't go into the details of the limitation, but among them we have no direct access currently to the matrices. There is a steep learning curve for the newcomers, and matrix mapping is not supported. I will come back to it later. So I worked on this refactoring, and I currently have this proposition. It's not done yet. It's still a work in progress, and I still have some components or features that are not been implemented. So just a warning, this refactoring will be breaking, and it's going to be released for version 22.06. So it means that your plugin or your fork or your your code based on SOFA will not compile, and you will need to make some modifications. And of course, I take this into consideration, and to make the transition as smooth as possible. One of the change that will occur in the design of the scenes is that there is a new component to add in the scene. This component is associated with the linear solver and describes the method to assemble the matrix. And it also owns the matrix data structure. There could be multiple methods available, and to maintain the backward compatibility, currently the linear solver creates a default component, so you don't have to modify your old scene for now. And the idea of this new component is to create and associate a local matrix to each component that contributes to the global matrix. Here, for example, we see that the uniform mass and the hexahedron FEM force field have each local matrices. A uniform mass has two local matrices because it's a mass and a force field at the same time. So that was for the user interface, and the changes in the C++ code. For example, if you want to implement a force field or change or adapt your force field, there is this new function that replaces the add k to matrix function. And the goal was to simplify the implementation of this function. So here we don't have the notion of the offset that was here to know where in the matrix to contribute, and there is no factor to multiply each matrix on entry. So if you understood well, everything is done in the matrix assembly component automatically. So it's not up to the force field developer to think about that. So as I said, there is this new kind of component. I call them linear system because it owns the matrix data structure. So it assembles the matrix from the scene graph, and for now it's called from the linear solver before trying to solve it. So the idea again is to create and associate local matrices to each component, and they are visited so that you can have local matrices to be built. And there are different kinds of local matrices depending on the type of component they are associated to. They are different depending on if they are, for example, a force field or a projective constraint, or even if the component is mapped. Because mapping, so mapping didn't work before. So the contribution to the mapping to the system, to the global matrix, sorry, was not transferred from a mapped node to a main node. So that's why we use this component mechanical matrix mapper to do this this job. So instead, we want to get rid of this component and do it automatically. So mapping the matrices that are in a map node to a main node, and that's why I introduce this data structure, mapping graph, where there is this the relationship between all the mapping and the mechanical states, and thanks to this data structure, I can know where in the matrix each component contributes. So yeah. And yeah, so basically this is the job that was done in the mechanical matrix mapper is now done in the matrix assembly component automatically, thanks to this mapping graph. So we also extract the Jacobians and for now we do the matrix project that was done in the mechanical matrix mapper.
And I'm sorry, I did not get who is holding actually this this mapping graph.
The matrix assembly component owns it and ask to build it. It's not something available to the user. It's just a data structure, a C++ data structure. It's not a component.
And I guess it gets updated as soon as you have a new node and a new mapping. It gets
the build is done at each time step. It's not
okay.
Costly because you just visit the mappings and the mechanical states, you know, and create the graph between them.
Okay.
So it's quite quick. And to finish, this is what I've done. So what I can support and what remains to do. So we can support force field masses, components that are force fields and masses, projective constraints, mapped components. I recently supported preconditioners, and what remains to do. We need to have a discussion on interaction force fields. There is a breakout room in the next 2 days, I don't remember when, where I can speak about the problem that I'm facing. Basically, there is the idea of removing them, but replacing that something else. We need to investigate a bit more the CUDA part. Matrix mapping can be improved in terms of performance based on what I presented this morning. And of course, we need to modify all the components with the new API. And there are some private plugins that relied on some mechanisms that will break. So we need to have a look on that too. That's it. So you can follow the project. I hope you can see my mouse on this GitHub project. That are the changes that are already in the public so far. And there is a fork of SOFA that on my GitHub account, and with all the changes that I presented in this presentation. Thanks.
Thanks a lot, Alex. Yeah, there is several people that needs to go for lunch here. So see you right after. I'll let you the mic again, and we'll rediscuss the matrix assembly this afternoon, as it will be further developed in the next 6 months.
Yeah. So yeah, this project is not finished, and we will still need to work on it. But the hope is that it will be released for the 22.06 version of SOFA.
Oh yeah, oh yeah.
So, if there are questions, maybe we can go back on this subject this afternoon. So keep your questions. We will talk about again about this subject. I suggest that we continue with SOFA NG. Fred, are you ready?
Can you hear me?
Yes.
Yeah, cool. So yeah, I can finally talk. So I will. I have to authorize again. A few minutes. Thank you.
Right. I don't have sound anymore. Am I the only one? I don't even see.
No, I was waiting for Fred to start, but
okay, you might have F5 or.
Are you there, Fred? Oh, we lost him. He's not in the conversation anymore.
Go ahead, maybe.
Yeah, never mind.
Yeah, I had to reboot the heavy application, but it doesn't want to connect anymore. So I'm on the light one now. So I hope I can share now my screen. Maybe. Yes, I can share. Okay, enter screen. Okay, you can see my screen now. Okay.
Yes.
Cool. Okay, so we'll speak again about SOFA NG. So I won't speak about goal and stuff because it's been a long time now we are discussing about that. So for the newcomers, you can go to the issue on the SOFA Framework repository, 1527. So the last task we have to do to implement was NG3, so the dispatching to the new architecture we convened last time. But there is a new one. I mean, inside this big task is to create a transition layer to make a smooth transition between the old SOFA and the new one. So since last time, we didn't really change a lot about the architecture, except something about the GUI and the topologies. It's not groundbreaking. So recap a bit what we want to do is to split, the file tree between the components between their nature. So one directory with constraints, one module with topology, one with FEM. So you can always see that proof of concept on that link, the FromAPAD link. Actually, I've done the proof of concept around so far, like only CMake files. So if you want to have a look, you can go to that link. Actually, normally it should compile with the latest SOFA, so you can have almost a real case of the SOFA NG new architecture. So you can have a look on the depot. The first level of the components will be like that. So I mentioned loop collision, strength, etc. So it's quite, straightforward. You can see what is inside. It's not like here and for now in SOFA base MISC something. You don't know what is inside. You know that in topology you have topologies, and that's it. So I generate, but it's not that clear, I guess. But if you can have a look, a precise look, now the CMake dependencies, this is the graph of the CMake dependencies, is much cleaner than the one we have now in the master branch. So you can have if you could zoom, you will see there is only one branch for the container, the one for GUI, the one for topologies, and etc. You can see below left down, you can see the SOFA framework, so the small round, and the upper part is the components. And you can see all the arrows is going to the SOFA simulation core, which is the entry point for all the components actually. So what we wanted, the goal we want to achieve for the users is like either in XML, Python 3, or C++, it would be to do the same. Like in XML, you will do, if you want to use a Lagrangian constraint, you will have to do to load sofa.component.constraint.lagrangian. So with the required plugin in XML, import with the Python 3, or if you do directly C++ code, just include sofa/component/constraint/lagrangian/ something, and for the namespace will be the same. And if in the future, not if, but when in the future we will have the C++ 20 modules, it will be almost the same line as Python 3, like import sofa.component.constraint.lagrangian. So it's quite just easy to read, and you know what you are using. Well, what we wanted to do is also, if somebody don't really want to care about Lagrangian or projective constraint, if you just want to use constraint because he doesn't want to know, he will just do import sofa.component.constraint. That's it. Or even easier, he just want to use Sofa components and he doesn't want to mess, to know where is what. Just do in XML, for example, I'm loading the plugin sofa.component, which will load all the sub modules. So that's our target actually. So what I've actually done for the last 6 months for SOFA-NG is one big task was to regroup all the algebra structure. By that I mean base matrix, all the classes inheriting from base matrix and base vector. So there was a lot spread in SOFA base linear solver and some other modules. So now we regrouped everything in only one module in the SOFA framework. The name is sofa.linear algebra. We could put some stuff about linear algebra in the future, but for now, we just regroup the base matrix and base vector. So we have a sparse matrix, a compressed row sparse matrix, and all the other I don't really know. And there will be also eigen matrix, I guess, in the future. So this allows us to remove a lot of useless links on SOFA base linear solver. So it's quite useful. Another part for the geometry and topology. So I guess last release we created sofa.geometry and the sofa.topology modules, but they were quite empty. So now I started to move some geometry algorithm actually used in SOFA, like in the masses or something like that. I moved them into static functions. So now you don't, it was a bit weird that if you wanted to get the area of a triangle or the volume of a tetrahedron, you needed to have in your scene tetrahedron, geometry algorithm, etc. So it was a bit weird. So if you didn't instantiate that in your scene, you couldn't compute the area of a triangle. So it was a bit weird. So there was a lot of work in diagonal mass and mesh matrix mass. I've done the same for the topology function, like to get all the hexahedra around a vertex or something like that. And one other big task, it was to remove a direct dependency on the topology, the implementation of topology called something set topology container. So triangle set topology container, quad set topology container, and so on. And instead to use the higher in the hierarchy, the abstraction base mesh topology, which makes much more sense actually, because if in your scene you have a grid with hexahedra, you couldn't use some components who wanted to have some hexahedra, but he wanted an hexahedron set topology container, and both of them have hexahedra. So now it allows us to have more components using a more different type of topologies. And actually, my goal was more to remove a lot of dependencies on SOFA-based topology. So now a lot of modules are using the SOFA core /topology abstractions instead of the modules of a base topology.
Fred,
Yes.
I'm not sure I understand this part. So in the near future, when we want to have like FEM mesh using hexahedral elements, do we still need to use these topology containers and things like that?
I don't know which FEM you are. I didn't see the FEM for now, but normally, I mean, the FEM is expecting a topology with hexahedra, not a hexahedron set topology container.
Yes, I agree.
So I mean, that's my goal. What I've done for the diagonal mass and stuff. So in the future, for me, it's like if a component wants topology, you want, you will do. Well, for now, it's base mesh topology. I guess you are interested in the what's the name? Cigogne topologies, I suppose. So I guess this is not inheriting for base mesh topology because it's not a mesh topology.
Yeah.
But I guess in the future it will be much easier to swap between different types.
Maybe just to complete your answer, Fred. So to answer you, Stefan, the idea is if you have a FEM, it will have a link to a topology. Just the topology will just give, okay, this is the list of my hexahedra. And then in the FEM, you would access the geometry module by saying, okay, compute the volume of this hexahedra, and it gives the hexahedra, and it's a static method.
I guess you're speaking about another thing. There is a container containing the topology, and the stuff computing like function on it. You know.
Yeah.
Yeah. So that's what I mean. I spoke about the two, both of them. Is like the container itself is at the bullet point, and what you are speaking about, Eric, is about the first bullet point. Is like how to compute. Area of the triangle, but give me just the 3 position. I don't know how you gave me them, but just give me the 3 coordinates and that's it. You know. So we are really like splitting. I mean, breaking the dependency between the two.
Yeah, which is good.
Yeah, that's for sure. I mean, okay. Well, anyway. And at the end, I also moved some topology change. It was in Sofa-based topology. For me, it was not really making sense, so I moved them to sofa.core. Because for me it was much more like logical to have them in the same like namespace, and and so what nice effect is like much more code now is compatible with other topologies like grid, some weird topologies like quad topologies I just saw or something like that. But maybe in the future like the Cigogne topologies, something like that. We still need to work on the abstraction of what is topology, image topology, etc. But it will be much easier to implement actually. So for the I've worked like the past last month about the transition. So because if we do the software, I mean the moving like roughly, let's say, a lot of users, I mean actual users will be like disoriented. So we need to make it as smooth as possible, like as compatible as possible. So for sure, we need to ensure that the existing code will use the new structure, but still for at least 6 months or 1 year, should still be able to compile their actual plugin with the new SofaNG code. So the good thing is like I already had some experience with compatibility things when I was doing the cleaning of Sofa framework. So that's why there is a sofa.compat module which is doing the redirection between the new and the old path. So to warn the people that it moved, but it's still working. So I'm planning to do the same for the component itself. So I would do a sofa.component.compat or something like that. I still don't have the name. But at the end, for sure, it will be quite a long task to do, but it's not that technical. So I'm not expecting a lot of technical problems. I mean, to change the path would be super easy. Just include a file into another file. The more tricky stuff would be to change the namespace of all the not all the component, but like 99% of the component. But the only problem I remember I got with the sofa.compat is like the code which is using stuff, but without including the headers because it's implicitly included by somebody else. So that's I cannot predict that, so that will be hard to manage. And also the forward declaration, because there will be a problem of using type def in the path of in the chain of the using. So this I cannot really fix that. I don't know how to fix that actually. So there will be some compilation problem, but I would say less. I hope that less than 10% of the code won't compile directly. So I've done a proof of concept of that transition for the audio solver components. So you can see the pull request on the 2455. So you can see on the right the structure of the code. So you can see the SOFA, let's say the SOFA directory, and then a component, and then inside audio server. And inside there is a long path, but at the end it's backward. And for the audio server, we split into two categories, backward and forward, implicit, explicit, and like that. So and the compat directory. So surprisingly, it was working directly, almost directly, I think. And so even the tests are working. Of course, there is a lot of deprecation warnings, but I mean that's the purpose of that proof of concept. So I'm a bit surprised, but at the end, audio solver is not really used actually in other plugins, so that's why it was an easy case. So and what I'm saying is like what I'm saying on the second point. I'm expecting problem with special template instantiation or like tricky things, especially in SOFA-CUDA. But SOFA-CUDA is already quite old and stuff, so it's not a big problem, but we will see. But I'm expecting that it will be long to do, but it should be okay for a majority of normal users, let's say, not super advanced ones. And that's it. And I didn't know how to do also the to-do, or maybe it will be this afternoon or now, I don't know. But what I'm planning to do is to, as soon as we release 21.12, I will, for 22.06, I will directly start the reorganization. So for each, my plan for now is for each component type, so like all the folders you saw last time, I will do one PR, so moving the files, the namespace, and everything around, and the compatibility attached to it. And I can, like that, I can see for each PR which one is breaking what. It will be easier to fix. And like I say, it will be quite long, but not that difficult technique for speaking a technical point of view. And for the other plugin, I don't have access, so I will not know if it's breaking or not. I hope for those repository, we can create CI jobs especially for that task, and like that we can detect as soon as possible some technical problem which is more difficult than just one header to add or something like that. And that's it for the SOFA-NG part.
Thank you, Fred. We have a little bit of time for just maybe one or two questions. And again, this subject will be rediscussed this afternoon.
If there is no question, I can say what I've done this past 6 months, except SOFA-NG, because I couldn't speak just before.
Sorry, François said in the chat, I have to say I'm a bit surprised with the naming convention for directories with sofa.library.things. It's the first time I see this convention, but is it right to say that we will have dots in the directories?
Directories, no.
Yes, that's what I
not
thought.
in the directories, but in the
Yes.
DLL or libs or
yes.
in the C++ module or Python module.
So François, if your concern is just on the directories things, there will be no dots and nothing like that. But if it's on more generally, like all the DLLs and stuff, yes, it's It's a bit surprising that you never saw that before, because I thought it was used by other projects.
That's what I
for Python. I mean,
yeah, that's what I wrote. It was
made to mimic Python 3 structure. Like a dot is a slash for path, kind of something like that. But at the end, at the beginning, I was like you. I was a bit surprised about that information. But at the end, it works quite well. Actually, it's easy to do in CMake, so it's not that difficult.
Shall we let Fred, making the update about the? I mean, give some time for the other topics, because you are always referred as NG, but you did other stuff. Give us some time, and shall we restart hearing about AI? I'm sorry, Robin, but I think there will be also. I mean, everyone will be maybe a bit fresher right after lunch, because here we already lost some guys, and I think it will be better. Yeah.
Is it okay for you guys?
What would be right after lunch?
Like
1:30.
In an hour, 1:30. Yeah.
1:30. Okay, I should be back. Okay, yes, I prefer this option as well, because I think we.
Okay.
I mean, we lost already quite a few people. And congrats, Fred, again for the progress on Sofa NG.
I thought that, but now I can see the light.
Yes, cool.
Fred, go ahead if you want to speak about a bit of latest and future.
It's really it will be. I will not share. But basically, it was just a lot of bug fixes, a lot of cleaning, a lot of stuff about around like how to compile on the Mac M1, Qt6, a lot of support for Windows for about all the plugins, and the small stuff I've done for 2 weeks ago, like when we had some days off. I've tried to put Sofa on the PIP, pipeline. So now for Windows, with Sofa Python 3.9, you can do pip and style Sofa framework.
Oh, yes.
On Windows, it's only for Windows. Because for Linux, it's much more complicated.
Yeah.
But for Windows, what I've done is created a VM, install Python 3.9, pip install Sofa framework, and Python 3 liver.py. I don't remember one of the examples, and it's working perfectly. So I was a bit surprised, but so it was fun to do. So on Windows, so you can have Sofa really fast actually now.
And what is the mechanism? It's installing binaries.
Yeah, it's what they call the BD or B package. Actually, it's a wheel. It's one paradigm. It's a pipeline or PPI. I don't know the pronunciation. But you are creating kind of packages either with sources and binaries. So I just done the binaries one. I think how I did it is really dirty. I think for the Python point of view, but it was working well because I'm shipping Sofa and then the Sofa Python 3 binding in the same time. So it was a bit weird to do, but at the end it's working well. So it's fun. So for now, I put it on the PyPy test repository because you cannot remove the package afterwards. So you have to be really careful when you put package in it. So I will copy paste the line if you want. If you're on Windows with 3.9, you can normally test that.
So the binaries are hosted on their servers?
Yeah.
Okay.
So the DHI test PyPy is to mean that I'm using the test repository of PyPy. PyPy or PyPy. But it means that at the end, if we are sure that everything is good, we can put on the normal repository. And so we can do pip install Sofa framework directly.
So cool.
So it could be nice to, as we are now specifying the Docker links, the Docker containers for some of the operating system, it could be cool to have that line as well if people want to do test.
Well, the thing is, after you need more systems because it's only Windows, and I did for only Python 3.9, and you have to do that for each version, so it's a bit bothersome actually.
Yeah.
So we could also we could also rely on this for the GitHub Action stuff.
We could, yeah. Especially for people who are doing just Python 3 bindings for Sofa, you can just pip install Sofa framework and that's it. Yeah.
Cool. So yeah, definitely we will talk about this again. It is pretty recent.
It was 2 weeks. I mean, when we had the bridge days.
Okay.
When I was in oh my goodness, when I saw Stefan. Yeah,
Nice.
I was doing that.
Okay, so I suggest that we go to lunch now.
Yes.
We come back at 1:30. I will just show it on the screen. We come back at 1:30 for the 4 remaining presentations. Actually, mine will be very, very quick. So I can say three remaining presentation: Coursera, SOFA and AI, and topologies.
Of Maxime earlier of update, you mentioned that they were looking at making things more and more engine-like. So it sounds completely directly related. Okay.
The problem is, just to make it very short, the thing is the mechanical objects are using a list of DOF, and this list of DOF might be changed if you are doing some topical change, but you need to update all the information at the in the right order. And with the mapping, it's quite hard to have the right order.
Okay, cool, thanks.
So again, as I said, for all the other projects, this project could also be discussed in the breakout rooms right after, because as you said, Eric, it will be on the next roadmap. So to just conclude, there is one project that has not been presented. It's this one. So the user experience and developer experience. So we decided last time at last STC to put really an emphasis on this user experience and dev experience project. So we wanted definitely this to be improved in 6 months. So here are very quickly the things that have been done in the last 6 months. A bit of documentation, thanks a lot to Alex, who contributed mostly on this, and Hugo also. A lot of support on the forum and directly with you guys, with the teams, INRIA teams in particular. A few things around the framework itself. So that's what I said during the roundtable. Things around deprecating stuff. Fred, you did Doxygen in code, yes, and it's important to say it, so you're right. Thank you for that. Deprecating stuff. So this is something definitely that I'd like to continue working on, even though I don't think it should be a roadmap task anymore, because it's something that is really going on and on through all the releases, and actually should not be really focused on in the roadmap. External project detection. So this is something I guess I presented at the last STC. So it's a feature that is used now more and more. So I guess it's okay for you. So just to remind, it's the feature that permits you to link a pull request with external projects, so external plugins, to have some sort of synchronization between external projects and SOFA. I see a lot of messages popping in the chat, but I don't have time to read them.
I'll let you know if you go ahead.
And sorry, I clicked. Sorry for the epileptics. And lastly, some CI/CD and tools work joining this dev, mostly the dev part, the dev experience part, not anymore the user part, more the dev part. Some work very recently around Docker to make it possible to run SOFA with GUI through a Docker container. So this is feasible. It has been tested. Yes, thank you. It has been tested and is feasible. It was tested only with Ubuntu host for now, but hopefully I will do it also for Windows and Mac OS. It shouldn't be very complicated. A lot of work around Sofa Python 3 for the CI stuff and GitHub Action stuff, and also moreover around this GitHub Action work, a more generic work for to help every plugin maintainer to work with GitHub Actions. So this is something I wanted to present more into details now, but since we are short in time, I propose to keep the presentation for the slots that has been set. So I can show you here. So this is the slot. So it's Friday at 1:30. I planned two slots. So actually, it's the whole afternoon to do a workshop to help you guys set up a CI for your plugins with GitHub Actions. So I will do the presentation that I plan to do now. I will do it here on Friday afternoon. So I will do the presentation, and then I will help you with your own plugins, getting your hands into that. And that's it for the user experience and dev experience. I guess we will not really talk anymore about this. So if you have questions or remarks, it's best to do it now because it won't be in the next roadmap.